When you call a function, the compiler will create a stack frame for the new function call, and it will push items onto the stack here. So the data itself, the data put on the stack, depends on your compiler, the whether the code is compiled for the debug or the release build here. So, however, in general, there will be information about the parameters passed here, the information passed parameters and to the function, the return address here, and the address named the function call here, and the automatic variables here are located in this function here. This means that when you make a function call at a runtime, there will be a memory overhead and performance overhead from creating the stack frame before the function runs, and the performance overhead in when you clean this function up. So after the function completes here, so if a function is inline, this overhead does not occur because the function call will use the current stack frame rather than a new one. So clearly the inline function should be small, both in terms of code and the memory used on the stack here. So the compiler can ignore the inline specifier and call the function with a separate stack frame. So we can actually specify the cal conventions in this C++ here. So when your code uses your own functions, you do not need to pay any attention to calling conventions because the compiler will make sure that the appropriate convention is used. So however, if you are writing library code that can be used by other C++ compilers or even by other languages, the calling convention becomes important. So since this course is not about interoperable code, we won't go into much depth here, but instead we will look at two aspects: function naming and stack maintenance. So we can also use the C linkage here. So when you give a C++ function a name, this is the name that you will use to call the function in your C++ code. However, under the covers, the C++ compiler will decorate the name with the extra symbols for the return type and the parameters so that the overloaded functions all have different names. So to the C++ developers, this is also known as the name mangling. So if you need to export a function through the shared library, for example, in Windows, dynamic linked library, this means that .dll files for the shared library in Windows here .dll files here. So this means dynamic linked library. So you must use the types and names that the other languages can use. So to do this, you can mark a function with the extern C here. This means that function has C linkage and the compiler will not use the external code, and you should not use it with the function that have return values and parameters that use the C++ custom types, extern C here like that. So however, if such function does return a C++ type, the compiler will only use a warning. The reason is that the C is a flexible language and the C programmer will able to work out how to turn the C++ type into something usable, but it's poor practice to abuse them like this here.